In 8-5, we simply go backwards from what we were doing in 8-3 and 8-4. Today we're going to factor instead of multiply. The starting problem here is kind of fun. It says the area of a rectangular solar panel is given by the trinomial x squared plus 7x plus 12. The height of the solar panel is x plus 3, and they labeled that over there. What could be an expression for the length of the panel? Well, you guys know that the entire thing is x squared plus 7x plus 12. And you also know that it's going to be length times width, or height times length, whichever one you want. They already gave you x plus 3, so the question is, what would these two be over here so that you got x squared plus 7x plus 12? Well, some of you might already be thinking that we are going to have to do this whenever we're done. So the question is, what numbers go in here so that we get an x squared when we multiply the first and the first? How about an x? That gives us x times x. And then what number gives us a 12 in the back? What about a 3 and a 4? Because 3 times 4 is 12. Now take a look. If you did the inside numbers, if you did 3x here, and then you did the outside 4x, wouldn't 3x and 4x combine to give you a 7x when you add them? So you could kind of go backwards and figure out that width would be x plus 4. So today we are just going to go backwards. We're just going to factor, that's the word, instead of multiply. Now I'm going to teach you what to do, and this is a trinomial today. We're only going to focus on trinomials. What to do if the last number is positive. Okay, let's try this. Well, we know how to get here if we were given a double parenthesis, right? If we were given a double parenthesis, we would do the arcs, like the distribution, and multiply through and combine our like terms. Well, today, going backwards, instead of multiplying, we actually kind of think of dividing. So you're going to focus on this positive 15 in the back. Let's think of some factors of 15, okay? Because we know that they're going to go here and here. Okay, the factors of 15 are going to go in the two boxes. How about that? Let's try a couple. Now you guys know that 1 and 15 makes 15, right? And you also know 3 and 5 gives you 15, right? So we kind of have to make up our minds. Do you think 1 and 15 is going to go in these boxes, or 3 and 5? I'm hoping that maybe you're trying to process it through and get to an 8 here. Okay? Let's try it. If we add 1 and 15, we're going to get 16, aren't we? Whereas if we add 3 and 5, we're going to get 8, aren't we? We see that 8 in the middle? That tells you to choose 3 and 5. X and X go in the beginning. These are both plus. Now if you do your distribution and check, you will see that it is correct. Let's just check this one time to prove it. So x times x would be x squared. Remember, this is just the check. X times 5 would be 5x. 3 times x would be 3x. And 3 times 5 would be 15. Well, wouldn't these two things in the middle just combine and give us x squared plus 8x plus 15? Look how that matches what we were given. This is the correct factored form. Let's try this again in the got it. Let's try to break 24 down into some things we know. You guys know 24 is made up of 1 and 24, right? You also, I hope, know that it's made up of 2 and 12. And finding all the factors, you got 3 and 8, 4 and 6, and then from there on I would do 6 times 4, but I already have it. These are all the different ways that you can multiply to get to 24. Alright, you see this plus sign? That means we're going to add these numbers on the way down. What number are we aiming to get? This 11 right here. Okay guys, go through your choices. Which one of these choices makes 11? Hopefully you're answering 8 and 3. That means that's your answer. So when we do our double parentheses to factor it, we would do x and x because, or not x and x, excuse me, this one is, and it's r and r, not x and x. So we'll do r and r, and then 3 and 8. A lot of people will say, can I make that 8 and 3 instead of 3 and 8? Absolutely. These are both plus because we needed a positive 11. That's the factored form. Okay, now take a look at problem 2 and examine how it's different from the last problem that we just did. You might think it's exactly the same. Well, it's pretty darn close, except for that minus sign right here. All right, well, let's think of some factors of 24. 124, 212, 3, 8, 6, 4, or 4, 6, whichever, really doesn't matter. Which one of those make 11? 3 and 8. Let's put them in. X, X, 3, 8. Now this time, the 11 would have to be negative. So make both of those signs negative. Let's double check and make sure that that would give us a negative 11 and a positive 24. This is our check. All right, x times x is x squared. X times a minus 8 is minus 8x. Negative 3 times x is minus 3x. Negative 3 and negative 8 gives us that positive 24 that we were looking for. Look at how all of our signs match up exactly as we need them. This is therefore the correct factored form. Try another one with a minus sign in the middle. Let's think of some factors of 8. 1 and 8, 2 and 4. That's it. Which one of these makes 6? 2 and 4. Let's put them in parentheses. This time we have the letter y. Now remember, when we add them, we need to get a negative 6. That means both of these need to be a negative. Okay? So our goal here, let's make sure we're clear. If you add them, you need to get a negative 6. If you multiply them, you need to get a positive 8. Does that work? It sure does. Up here you could have done the same check. Do they add to equal negative 11? Yes. Do they multiply to equal positive 24? Yes. Alright, let's keep going. What if the last number is negative? Well, if the last number is negative, let's just make a note. You're going to have different signs. In fact, let's go back and make a note on the front. If the last number is positive, did you notice what we did? The signs are going to be the same. Okay? See how these were both plus, both minus, both minus. Okay. Let's do problem 3 together. What is the factored form of x squared plus 2x plus minus 15? Well, let's think of some factors of negative 15, okay? How about 1 and negative 15? How about negative 1 and positive 15? How about 3 and negative 5? Or how about negative 3 and positive 5? Let's add those options up. 1 plus negative 15 would be negative 14. Remember, we're trying to get to this middle number, and when we add, but we need to get to this last number if we multiply our choices. Okay? To get to the middle number you add, to get to the last number you multiply. Okay, and that's going to give us a positive 14. Neither one of those is right. This is going to give us a negative 2, and this one's going to give us a positive 2. Can you guys see how only one of these choices work? It's the last one. Minus 3 and a positive 5. So when we do our double parentheses here, put x and x, put a minus 3 and a positive 5. If you want to do the check, go ahead and do that. X times x is x squared. X times a positive 5 is plus 5x. Negative 3 times an x is a minus 3x. Negative 3 times a positive 5 is a minus 15. Put these two together to get a positive 2x. Can you see how the check helps us to determine that we did it right? So when you have a negative in the back, you use different signs, and when you use your different signs, you make sure that when you add them, you get the middle number, and when you multiply them, you get the back number. Let's try it again. Let's get our double parentheses down. This time, it says n squared, so we need n and n. We know our signs are going to be different. And we know we need to add to get a 9. And we need to multiply to get a negative 36. Let's think of some numbers that multiply to 36. Okay, add. Now I'm going to write or subtract here, because if you think about adding negatives or just subtracting regular. Alright, let's go ahead and think of some things that make negative 36. What about 2 and 18? Will that give us any type of 9? No, that won't give us any type of 9. Let's cross it off. Let's try 3 and 12. Could 3 and 12 possibly give us a 9? The answer is yes. And what kind of 9 do we need? A positive 9. If I make my 12 positive and my 3 negative, I hope you agree with me, that would give us the positive 9 that we need. So therefore my answers are a minus 3 and a plus 12. It's a lot about a game of guess and check, isn't it? The area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? Okay, so the whole area can be represented by that equation. Let's go ahead and try to think of a length and a width that would work. Well, let's break down negative 35. Let's just try some numbers. What do you guys think? Will 1 and 35 work? No, because we need a 2. What's something else? A 5 and a 7? Could that work? Yeah, we can get 2 out of 5 and 7. Now the question is, we need to get a, you guys see it? We need to get a negative 2. So should the 5 or the 7 be negative? Hopefully the 7. And the 5's a positive. That will give us a negative 2. So let's do x and x. Let's do a plus 5 and a minus 7. That describes the length and the width. When I multiply, I get negative 35. When I add them, I get negative 2. Let's try it one more time and I got it. We have another rectangle. X squared minus x minus 72. Don't forget, that's really a minus 1. Okay, it's like a game of guess and check. Can anybody think of two numbers that make 72 that also make 1? What about 9 and 8? Does 9 times 8 give you 72? Yeah. Now how could we get a negative 1 out of that? If the 9 was negative and the 8 was positive, that would give us that negative 1. Let's do a double parentheses. X and x minus 9 plus 8. And just so you know, this is the exact same thing. I don't care which way you write it. They're both correct. Okay? Either one. Let's do our check. Does this multiply to negative 72? Yes. Does it add to negative 1? Yes. We've done our job.